almost forgot, Mr. Kubitz. Figure number 3, we had what, 6 blocks? Then we had 10 blocks. And then in figure number 5, if we did that correctly, we should have had 15 blocks. See if we can find that pattern, because this is now 5. We want to get to the 10th figure. So see what you think we would have for the 10th figure. All right, and see if we can do that. I'm going to leave you a minute to try that one. I'm going to make this a little smaller on my end. We did one of these yesterday where you had to recognize this pattern. Okay, Walker's on the board for 55. Let's see if Walker's good. I really have to do this myself real quick. I did do it yesterday, I don't remember. Let me open up my chat so I can see these. Oh, Andrew's on there for 55 too? Good. Anybody else getting 55? We're still working. See some heads nodding. All right, I saw Andrew first. Where's Andrew? There he is up there. Andrew, those are some cool lights you got in the background going on, man. Like it. All right, Andrew, can you unmute and tell us what you did to get that? What did you think? What was your thought process?
Well, I just kept counting because it kept going up by like 1 each figure. I kept like adding.
Good. So like what he's saying here, this one increased by 2. This one increased by 3. So see how that's, we increased by 1 in that second difference. This one went up by 4. This one went up by 5. So then he understood we were continuing to increase by 1. So the 6th one would have had how many, Andrew? Did you show them all?
21.
Good. So that would have been 21. The next one should have increased by 7. So that would take us to 28. And if we continue on with that pattern, the next one should increase by 8. Gets us to 36. Hopefully I can squeeze this in here. 9 gets us to 45. And then that 10th and final one that we're looking for would be increasing by 10. And then that would take us all the way up to that 55. All right. If you didn't get it, any questions on how that just played out? All right, does that make some sense in terms of our pattern? Here's what I want you to add to this then, if there are no questions. And this is what we're going to get at. There's going to be a question or two tomorrow pertaining to this. So right now, do we have a common difference? So in terms of being linear, are we increasing by the same amount each time? If this one increased by 2, 3, 4, 5, are those increasing by the same amount every single time? No, not the first difference. So let me do this here. What we call this first one, and this is all you would have dealt with last year, is our first difference. And it's different every single time. This one increased by 2, this one increased by 3, this one increased by 4, 5, 6, so on and so forth. But what we do have here, let me see what color is going to work. If I go from here to here, what this second row is called, and we mentioned it I think yesterday, this phrase, this is our second difference. The second difference increases by 1 here. It increases by 1 here. This is what Andrew was saying when he said he saw that those are increasing by 1 every single time. Increasing by 1, and then increasing by 1. So while we don't have a common first difference, which is what you would have been looking for last year, what we do have is a common second difference, and that common second difference is a 1. All right. So when you now go down to number 3, when it asks, examine the sequence of figures, determine if the rule for the number of tiles in any figure is represented by linear, exponential, or some new function, what led to that conclusion? So when we would have done these, in order to be linear, this first difference had to be the same, and it isn't. We increased by 2, 3, 4. It's not the same thing every single time. So it's definitely not a linear function. Exponential, I think we all remember that yesterday. You're multiplying by the same thing over and over and over again. That pretty clearly is not happening. What we have here is a new function. So we haven't defined it yet. You're going to do that now. The new function that we are talking about when we don't have a common first difference or a common ratio, but we do have this. So if we have a common second difference, what that function is called is a quadratic function. So when it starts using the general term new function, that's our new function. So in terms of linear exponential, you dealt with that a ton last year, endlessly last year. You would have talked about those things. And then the new section is going to review that and then introduce you to the idea of what a quadratic function looks like. All right? All right. Any issues with that before we move along here? Good. All right. So with that, call my time. Good. We got a little bit of time here. Go to, because I'm going to give you some homework, but go to number 7, letter B. All right. Actually, you know what? Just do A, B, and C. Don't worry about the equation right now. Similar to yesterday. Just do A, B, C for the table. And then tell me if you think those tables are linear, exponential, or now we can use the word quadratic if we recognize the pattern that we just talked about above. All right? Yes, Kim.
I actually think yesterday and I actually have a question for the equation.
Okay.
Should I just wait till everybody gets it?
Yeah, because quite honestly, we're not going to write the equation for that guy just yet. That's something we're going to do on a different day because it can be a little sneaky. It's a little tricky. So I wouldn't worry about that guy. Good, and that's what you want to be looking for now that we've defined it and we talked about it. So that means it's going to be what type of function then for letter B?
Quadratic.
Good. Good.
Oh, okay, I see it now. Okay.
And that's what we haven't written that equation yet. We haven't done one of those just yet. That's kind of the point of this section. So we haven't done those. So it's good that you have a question because if you had an equation there, chances are it's probably not quite right. Although maybe you can come up with it. Actually, maybe I will because if you look at it, you might be able to come up with that by just looking at it. All right, so let's just talk about what type of function, and then it asks you for that characteristic that allowed you to define which one it is. So let's see how we did here. So for letter A, I'm going to call in some people because I think we probably are okay with these. Let's see. I'm going to go. All right, Nora, what do you think for 7A, Nora?
I said it was a quadratic or exponential.
Good.
It was divided by, or divided by 2.
Good. So she said it's exponential because she says we are multiplying by 2 the whole way down. So times 2, times 2, times 2, and then times 2. All right, good. We'll get the equation in a second. Cam, you kind of already let the cat out of the bag there. What'd you say that guy was?
A quadratic function.
Good. That's our quadratic. I'm also picking you because you used the right vocabulary there. As you now looked at it, what couple words did you just use a minute ago that you recognized?
The second common difference.
Good.
You're going up by 2 stuff.
Good. We have a common second difference. So if we were to do what you did last year, this increased by 13, this increased by 15, this increased by 17. So we would have said last year, no, that's not linear, that's not exponential. All right, and that's all true. But what we now recognize, hopefully, we do this in red, if we go to the difference in those numbers, that one increases by 2, that one increases by 2, they would all be increasing by 2. So that's what he's referring to with the common second difference. That's when we're going to know that we have what's called a quadratic equation. All right. All right, C. Let me call on somebody here. I'm going to go Gabriella. How are you, Gabriella? Good. Do you have C? Think you can help me out there?
Yeah, I do.
Good. That's our third option. It's linear. What did you notice about that, Gabriella, to say that that's linear?
Adding 2.
Good. We have, I'm going to put, yeah, we'll put that, adding 2. Every time we have a common difference here of plus 2, plus 2, plus 2, and then plus 2. All right. Now the harder part, especially after a long summer, see if you can write the equation for those three. I'm actually going to go ahead and challenge you and see if you can do letter B, because I think you might be able to do that one if you just look at those values in the table, and you might be able to come up with that. All right, so try to do letter A. It's an exponential equation. If you need to look, you have your notes from yesterday. If you have those handy, slide those over. Recall what we talked about for writing an exponential function. Letter B, you're just going to have to kind of think on your head. I haven't shown you how to do this yet, but I think when you see it, you're going to say, okay, that makes some sense. And then letter C, again, it's linear. We've done plenty of those over the years, but it's just been a while. All right, so see if you can get those three equations. It's cool. I feel like I need like the Jeopardy music or something to break the silence up.
No. I don't like sitting here in silence.
Yeah, get a sound effect machine or something I'll bring in and add a little flavor.
There you go. It's excitement in the morning.
Yeah. All right, we'll do one more minute. See if we come up with these.
Is the second one y equals x squared?
Who's that, Bisher?
Yeah.
Why'd you get that, Bisher? What'd you think?
Because every single number is like the number times itself. Like 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64.
Good, good. There's a formal way to do it when it's not quite that nice. And that's why initially I told Cam, don't worry about it. We're not going to write that equation. But then as we really look at that, if we just recognize some patterns, if I do 6 squared, I'm going to get 36. If I do 7 squared, I'm going to get 49. And that's what Andrew was just saying there. 8 squared is going to give you 64. 9 squared is 81. So really all we're doing is taking whatever the x value is, and you are squaring that. Good.
The last one,
or Bisher did.
y equals 6 plus 2y.
Yeah, let's talk about those, because those we should be able to know how to do. All right.
Y equals 6 plus 2x.
Yeah, let's do 7 first, and then we'll go to to letter C, or let's do A first, and then we'll go to letter C. But this is what a quadratic is going to look like. Linear equations, if you remember last year, one of the characteristics you would have talked about with your teacher is that they have a power of 1. That's what linear equations always have. A quadratic equation now, if you look, simplest way to kind of think of it, it's going to have a power of 2. That's what every quadratic equation will have a power of 2. All right? All right, so let's go to 7a. So I think it was Bisher giving us some of these. So anybody besides Bisher, hold on, Bisher, I'll have you do that last one there. Anybody confident in their 7a that wants to throw that out there in front of 25 of your closest friends right now? Oh, brave souls.
I'll go.
Okay, what do you got, Cam? You're a brave man.
Y equals 64.
All right.
Times 2. And in parentheses, x minus 2.
That's beautiful, Cam. That's beautiful. So the A has to be whichever Y value you want to start with. He picked 64. So in that spot, let me erase here, maybe. So in this spot, Cam put the 64. This number here is whatever that common ratio is. So whatever number you're multiplying by over and over and over again. And we're multiplying by 2 every single time. So you're going to put your 2 in that spot. And then the exponent, since the 64 is paired up with a 6, that's why in the exponent, he said that should be x minus a 6. All right? Does that make sense? Any questions on that? You could use any point. So if you wanted to pick this point, this point, this point, just make sure you have them in the appropriate spots. Does anybody have a different one that you want to confirm is correct? Or are we confident in what you have if it's different than what Cam gave me? All right, we're all good. All right, cool. All right, next one then. Letter C. This is a linear equation, so this should now look like a line. All right, Bisher, were you giving me this one earlier? I told.
The last one?
Yeah.
Y equals 6 plus 2x.
6 plus 2x. All right. And again, with all of these, we could test all of them. So like we said, if I took 6 and plug it in, 6 squared is 36. If I took 10 and I plug it in, I'd square that. If we were to go ahead and plug any of these numbers in, I promise if you plug in a 7, this would give you a 128. So let's do a quick little check of this equation. So let's test 8. If I plug in an 8, this equation better spit out a 15 right now. So if we come down here, if this was right, we would do 6 plus 2 and then plug in an 8. 2 plus 8 would give you 16. 16 plus 6, will that give us our 15? No, okay, and that's good, all right? Throw that out there. I appreciate giving me some answers, but you can check your equation right now. So if you do have an equation written down right now, pick another point, plug it in, and see if it works. And if it works, you know you're right. And if it doesn't work, then we know we've got some tweaking to do. All right? Okay. Anybody think they have that? Another version? What do we got there? Nora, you think you got it? What do you think, Nora?
Y equals 11 plus 2 and 6 x minus 6.
Okay, so now let's test Nora's. So let me use this same point here, this 8 comma 15. So if we now come down here, let your x equal 8, this better spit out a 15. And if it does, then chances are we're correct. So 8 minus 6, we know is 2. And then take 2 times 2, that's going to give you a 4. And if I add 4, 2, and 11, will that give us our 15? Yeah, okay, so that's good. That equation we know is correct. So, How'd you get that, Nora? Where'd the 11 come from?
I started at the streets for the x, and then the f of x is 11. So.
Good. You can use any point in the table if you remember yesterday. Nora just chose this one. So that table starts with the value of 11. You can see here, we're just going to be adding 2 over and over and over again. So that's why she said I'm going to plus 2 over and over and over again. And then since that 11 has an x coordinate of 6, she put the x minus 6 into a parentheses. All right. I'm going to do a second one because this is actually one of your questions tomorrow on the little quiz that I'm going to give you. I'm going to give you a table of values, and I'm going to have 3 or 4 choices, and a couple of them are going to work because I want to make sure you understand we can write these equations a little bit differently. So real quick, last one for today. If you understood what Nora just did with this one, write the equation using this point. So now try to write the equation using the point 9, 17. All right, and we'll do that one underneath. That's right. All right, I'm calling somebody new, I think. Thanks, so Cam, I appreciate it. All right, I'm gonna go, I'll stick with people I know right now so I don't get new people mad at me just yet. Unless somebody, Walker, you think you got it? All right, what do you got, Walker?
I got y equals 17 plus 2, and parentheses x minus 9.
Good. So if we would have started our table here, we're still adding 2 over and over again. So he starts with 17, continue to add 2. Since 17 is paired up with that 9, you would get x minus a 9. All right. Be able to do that tomorrow. That is one of the questions. You're going to have a table on your computer, and I'm going to ask you which of these equations, select all that apply, would represent the equation for this table, and there's going to be more than one possible answer. Where there's really 5 here. We could write all 5 different equations, one for every single point that's in our table. All right? All right. We probably need to stop there to make sure that we finish. So for homework, I will put this on Canvas. There'll be an assignment underneath your assignments tab on Canvas. So if you go to Canvas, click on the assignments. I'm going to put that in here in just a second. You're going to take, when you're finished with this, take a picture. You're just going to upload that to Canvas, and then I can see that. I can grade it. I can give your points. So what I'm going to have you do, make sure we can see this. You're going to do numbers 1 through 6. And then on the next page, I want you to do 7D, 7E, and 7F. 3 more tables. You're going to look at your table, tell me what is it, exponential, linear, or quadratic, and then you're going to do your best to write the equation for it. All right, and then that's that. We'll talk about it tomorrow at the beginning. If you had any questions, we can answer it. And then again, I want to test my abilities more than anything to write this quiz on Canvas and see how it goes for everybody. All right. So if you have any questions, speak up tomorrow. That's about all I got. Mr. Kubowitz, anything you'd like to chime in with?
No. Thanks for being here. Thanks for participating. Thanks for having your cameras on.
All right. All right, if you have no questions, we'll see you tomorrow. If you have a question, you want to stick around a minute, you can ask before tomorrow, but other than that, we'll see you tomorrow, okay? Have a good day. Enjoy the rest of your day.
Bye, everybody.
All right. I gotta hurry up and put that on Canvas, I forgot.
Quick question. I didn't want to ask while they were doing it because I didn't want to confuse them.
Yeah.
For like 7C, do you always want them writing it in that form? Or can they write it in slope intercept form? Like they put y equals 2x minus 1?
No, they can do that. So the hard part about slope-intercept form with
You don't have the zero there.
yeah, you don't have the 0 for those. So I like to do point slope a lot more.
Okay.
Because it applies to anything. If you don't have the 0, it's harder to work backwards. But slope intercept form would be totally fine. Hey, bring that up next time. Because a lot of people do last year, because I have math 1, they always work themselves back to 0. So they just kind of like create the table and they get back to 0, and then they know they can do slope intercept form.
Yeah, I didn't know. I didn't want to ask you because I didn't know if that would just confuse them or not.
It might, but it's something they should know. Like that is something that they get mixed up on as freshmen as they're learning all of those. So it's just kind of part of that topic.
Okay, maybe next period I'll ask if anybody wrote it. We'll finish up.
Okay, yeah.
If anybody, or see if anybody can write it.
Yeah, that'd be a good idea.
All right.
Yeah, for sure.